Okay, we can go ahead and get started. So go ahead and get started. Where am I at? Okay, so if you haven't signed up for my math lab already, started recording, cool. Yeah, so if you haven't signed up for my math lab already, please go ahead and do so. I think there's 2 or 3 of you. You may be receiving an email from me saying, hey, you should probably do that. It's a little bit of a necessity for this class to have my math lab set up. And it's a good idea to have that set up fairly soon because the first assignment is due Friday. And we're going to be finishing up the material pertaining to the first assignment, hopefully today. If not, then I'll push it back if need be. That's fine. And as far as the upload to your drive thing goes, I'm going to start looking at those today now that the classes are now set. People aren't adding and dropping anymore, so I'll start looking at those today. If you send me any emails, I'll be going through those today as well. So besides for that, let's go ahead and pick up where we left off. So we are talking about graphs of a function. Who's the one on Snapchat? What?
I'm so sorry, but where did you send the Google Meet? Like, online?
It's under Google Calendar. Yeah. Is that you on Snapchat?
Yeah, someone.
Yeah, well, kill the notifications. It's rude. Kill them. All right, so we're talking about graphs of a function. And so we're going to be going through a lot of parts of this particular graph to start off with. And as you notice, there's a lot of parts. That's why it's better that I show you how to facilitate these rather than you go on these on your own. And some of these get a little bit tricky, so we'll talk through them in a little bit of detail. So let's go ahead and start off with some of the easier ones. So yeah, they give us a graph, and we're just going to make some observations about the graph. So start off with part A, find f of negative 14. So f of negative 14, the way that interpretation normally goes is, well, what it means for negative 14 to be in the parentheses, like it is here. It means that x is negative 14, and we find the y value. So we see it for this ordered pair right here, the x value is negative 14, the y value is negative 6. So that's it. Just more of an identification thing so far. F of negative 4, same idea. Where do we find negative 4 for x? I see it right here. What's the y value? Positive 6. We keep going. Part B is the same thing. It's just now x is 12. I see that right here. So when x is 12, y seems to be 6. And what about f of 0? When is there a 0 in the x position? I see that right here. What is the y value corresponding to x equals 0? Negative 3. So it starts off pretty tame so far. Just what's the y value corresponding to these particular x values? More so a way of interpreting the notation. So let's move on. Part C. It's asking if f of 4 is positive or negative. So f of 4 means, well, if 4 is x, then what is y? When 4 is x, we get negative 6. Is negative 6 positive or negative? Obviously, it's negative. So it's negative. All right, move on to part D. So this is where these problems start to step it up a little bit. For what values is f of x equal to 0? Notice that the 0 is not in the parentheses anymore. And that is because we are now addressing when y is equal to 0. When y is equal to 0, what is x? So we look at the graph up here. So when is the y coordinate 0? I see 3 instances of it. There's a y equal to 0 there. There's a y equal to 0 there. There's a y equal to 0 there. So all the places where 0 is the second coordinate. And now it wants the x values. So the x values, -12. The middle one might be hard to see. That's -2. And +8. So -12, -2, and +8. It's the x values that correspond to when y is equal to 0. For part E, for what values of x is f of x greater than 0? So for part E, I might do that work up over here on the left. Might need a little bit of room here. But first, let's think about this in an intuitive way. What does it mean for the graph to be, or what does it mean for f of x to be greater than 0? Well, f of x is a fancy way of saying y. So when y is greater than 0, I'm going to illustrate this in red. So these are the two components where the graph is greater than 0, when y is greater than 0, when the graph is above the x-axis. And as such, we need to use a compound inequality to denote these particular segments. So we have 2 segments, so we're going to do one at a time. We're going to start with this leftmost red arc that I drew. So with compound inequalities, or just inequalities in general, you find the leftmost point, the rightmost point, and with inequalities, you normally list the x values of those. So the leftmost point, what's the x value of that? It's -12. So for part E, -12 is the leftmost point. Rightmost point, what's the x value of that? It's -2. How do you quantify this as a compound inequality? What does that look like? Well, what that looks like is, well, you know how inequalities work. There's a variable and a number, generally. So we had -12 before. Since we're looking for x values, I'm using x. The -12 was the leftmost value, and the -2 was the rightmost value. And so that's how we generally denote intervals, just whether it's interval notation or inequalities. You find the leftmost x value, which we found right here. It was -12. And then the rightmost x value, which was -2. -2 might be hard to read, but that does say -2. But we're not done. We're not done because all we did was address the rightmost red arc that I illustrated. We still have this over here, that red arc. So in our example for part E, put a comma. We don't normally use unions for compound inequalities or inequalities in general. The leftmost point, what is the x value that corresponds to it? It's 8. You put an x in the middle because that's how a compound inequality is notated. And then what was the rightmost x value? Seems to be 12. But there's one exception here. So I didn't really address why I'm using less than signs as opposed to less than or equal. It says here, when the function is strictly greater than 0, which means exclude all of the points that lie on the x-axis. So the first 3 points that I identified here, the -12, the -2, and the 8, they lie on the x-axis. So I excluded them. I used strictly less than. Notice this rightmost point up here is not on the x-axis, which means I don't have to exclude it, which means I include it. So notice on the 12, there's now an equal to part. Part E is a little tricky, so that's why I wanted to point this out to everybody. So for part E, there is an equal to component for the 12. This would be your answer for part E. All right, part F, we're going to find the domain. And what's interesting about the domain, so we talked about the domain before. We talked about it last time in class. Did not watch that video, you missed that lecture, you need to watch that and get caught up. How do we find the domain? So last time in class, we found the domain when we had a function. Here, we don't have a function, we have a graph. So how do you find the domain? You have a graph. And normally I give some sort of association here. For the domain, pretty much the association, left to right, and x values. And we don't know how to spell value. Let's try it again. Value. This will make more sense as we do the problem. The domain, the association is left to right and x values. So what do I mean by that? Well, the graph goes to the left and the graph goes to the right. As such, and yeah, for Google Meet people, yeah, goes to the left, goes to the right. So find the part of the graph that is furthest to the left. Part furthest to the left is right here. It's the furthest to the left we can go on this graph. What I literally do when everybody's in class, I will take my finger and trace it myself. This is the furthest to the left you can go. The domain, so the domain says, I want the x value. So notice I boxed in an ordered pair, which has an x and a y. The x value is -14. So -14. This is still a compound inequality. So the notation is, I'm going to put less than or equal to with an x. So compound inequality, you have to have an x in the middle. The reason I'm including the equal to part is that the point I boxed in has a filled in circle next to it. That means it is included in the selection of x values that are applied to this graph. And there's no special condition like in part E, where they forced us to pick things greater than 0. All right, so that was the leftmost point. What's the rightmost point? It's right here. I think we can visually all agree on that that's the rightmost point. What is the x value of that point? It's 12. It's got a filled in circle next to it. So I am, again, going to use less than or equal to, and that's 12. So That would be the domain. Negative 14 less than or equal to x less than or equal to 12.
Why are you using less?
What's that?
Why are you using less than? About that time?
It's because the way the notation works, we have to build up to the larger value. And so what it's saying is that any x in this interval would have to be greater than negative 14, which would bring it to the right, or would have to be less than 12. So it's basically a minimum versus maximum dichotomy. So that's primarily why. If you were to flip the inequality, then it would say greater than or equal to 12, and that would imply values all the way over there that don't really exist. So that's another way of looking at it. So that would be the answer for the domain. So once you identify it, the statement of the answer is really not bad. But the identification may take a little bit of time. And we move on to the range in part G. I'm going to give another association, very similar to the domain, because the domain and the range are very closely associated things. We're just going to swap some of the terminology a bit. So like I did before, range. So I'm going to say bottom to top. So bottom to top and y values. So I pretty much flipped everything. Instead of left and right and x values, it's bottom to top and y values. So let's apply that logic here. So the range, we need to find the lowest point on the graph. On bottom to top, we need to find the lowest point. There seems to be a tie here between these two. Seems to be a tie between those two values. They're both equally, they're aligned horizontally. They're both equally as low. That's okay because they both have the same y value. But yeah, I said bottom to top, and now we identify the y values. So what is the y value of the points that I boxed in? Well, they're both -6. So we start off with -6. We're going to do that. It still says compound inequality, so we're still going to use this notation with an equal to part because those points are filled in and there's no other special conditions that they're applying to this problem. Instead of an x, I'm going to use a y because we're looking for y values, so it makes sense we use a y. So what's the highest point on the graph? Yeah, it seems like you're all ahead of me, which is perfect. I'm not going to complain about that. So that's the point that's the highest, but we want the y value, which is exactly the 9. I'm going to put less than or equal to for the same logic as before. I'll put the 9, we're done with the range. Again, it might take a little bit of time to interpret it, but once you do, the statement is normally pretty straightforward. There's no computations or graphs. At least not this type of graph. Let's move on to part H, which wants us to find something called the x-intercept. Exactly, it's when y is 0. So what is an x-intercept? So I haven't formally defined it yet. That's when, in other words, y is 0, or if you're given a graph, you can think about it as when does the graph cross the x-axis? So eraser, let's get some of this stuff out of the way. So yeah, the x-intercept is when y is equal to 0, or in other words, when does the graph intersect the x-axis? So the x-axis, just as a reminder, is the horizontal axis. It goes all the way across just like this. So when does the graph cross that? I'll illustrate that in a different color. It seems to cross it here. Notice when y is 0, It's not a coincidence. It might be hard to see, but this point does correspond. The point does correspond to the ordered pair that I boxed in, and this point as well. So I just boxed in all of the x-intercepts, all the places where the graph intersects the x-axis. Or in other words, when y is 0. And all it wants us to do is list the x values, because it has x is equal to blank. So what are the x-intercepts? I see -12. I see -2. Middle one, again, might be hard to read, but that does say -2 and 8. In fact, we already did this problem in part D. It's two ways of asking for the same thing. What are the y-intercepts? So naturally, the y-intercept just flips the logic applied to the vertical line. So where does the graph intersect that? Again, I will use red. Again, this graph's a little wonky, but that is, in fact, the correspondence between the point and the ordered pair graphically. So the y-intercept is when x is 0, when x is equal to 0, or in other words, when the graph intersects the y-axis. So what this wants, notice it says y is equal to blank. So what is the y point? Just -3. Just -3. Okay, so from there, we move on to part J, which is how often does the line y equal 1 intersect the graph? Line y equals 1. What does that even mean? So let's get rid of all this stuff here right fast. Actually, I want red. So what does that mean? The line y equals 1. So the line y equals 1, well, the y-axis is the axis that goes vertically. So you would think y equals 1 is a vertical line. Not necessarily. It's going to be the graph that goes horizontally that passes through y is equal to 1. So it is a horizontal line. That line in red is, in fact, the line y is equal to 1. And so the question now is, how many times does that red line intersect the graph? You just count. Just 3. 1, 2, 3. That's it. So 3 times. So naturally, we extend this to, what about the line x is equal to 4? So the x-axis is the horizontal line, but x is equal to 4 is going to be a vertical line. In fact, it's vertical and it passes through, guess what? X is 4. So in red, again, actually I'll do this in blue. That is x is equal to 4 because it passes through the x-intercept at 4 for x. And how many times does that blue line intersect the original graph? Just once. Just one time. One time. Finally, for what value or values of x does y equal -6? So let's erase some of these details up here. So what values of x correspond to y equal to 6? And notice the -6 is not in the parentheses, which means it is not an x value, it's a y value. So I see two occurrences of this. Two places where y is equal to -6. What are the x values? Just simply -14, and what is that, 4? So that's it. Same thing for the next part. It's the same exact problem, just different y value. Y is 9. I look on the graph to find, where is y equal to 9? Right there. What is the x value that corresponds to that? Just -6. So that would conclude this problem. This is not representative of the other types of problems of this caliber in the homework. There's no other problem that asks you for 15 parts like this one does. So this one's just one of the hardcore ones that I picked out. But as far as identifying various other factors of a graph, we're going to be practicing those momentarily with additional problems. In-class people, do you have any questions about anything so far? Let me check on my Google Meet people. Oh, I didn't address, okay, I'm seeing the comments now. The numbers are, in fact, different, a little bit different for that one problem. I had the wrong numbers before, so the numbers I had in my notes now, those are the ones that you want to use. So I updated the notes in my math lab already. So that's all I changed. It was maybe the first, A through D. So just go ahead and change those numbers. But I did fix it in my math lab though. So that was just typo on my end. So, all right, cool. So yeah, if you haven't done so already, go ahead, screenshot this. In-class people, you're allowed to take a picture if you want, and you can check the video if you'd like. But other than that, you take your picture and then cool. All right, let me go ahead and erase all of this and we'll move on to the next problem. That's not the eraser. There we go. All right, cool. So move on to the next problem. And we move on to something, well, we're going to talk about briefly the vertical line test, which some of you may be familiar with. Vertical line test is a way of, if you're given a graph, of checking whether the graph is a function or not. A graph is a function if any place you draw a vertical line will intersect at most one place. We can actually see that below for these two graphs that I have for example 2 here. So I'll use these graphs as an example right quick. So for this graph on the left, if you draw a vertical line anywhere, it should only intersect the graph at most one time. If it intersects 2 times, it's not a function. Same thing over here. Nope, that's not a vertical line. Oh well. Same idea though. Any place you draw a vertical line, as long as it intersects at most one time, it is a function. So that's the vertical line test. That actually answers the first part of these graphs here, because it does say, determine whether the graphs below are that of a function by using the vertical line test. We just did that, they're both functions. So we'll move on to finding some various characteristics about them. So we're looking for the domain, the range, so some stuff that we already found before. We're just going to practice it a little bit more. So for this graph on the left here, the domain of it, so remember the footnote that I gave before. Domain, left to right, x values. In this graph, I think we can all see visually that the leftmost point is right here. I think we can all agree on that. Domain says, I want the x value for that point. Yes, that's a good question. What is the x value for that point? It's negative pi. So they didn't give us an ordered pair like the previous problem, but this value, this x value is negative pi right here. So this is, that's negative pi. And what the problem does also say, it says put the answer in interval notation, not a compound inequality. So please see my last video on how to construct an interval notation. But we'll start off with negative pi. In fact, I'm going to use color black here. Dry erase. Erase that. So negative pi, and remember with interval notation, we use either a bracket or parenthesis for every number. For negative pi, we're going to use a bracket. And the reason why, so bracket means inclusion. We include negative pi because the point over here, right above here, it's filled in. It's a filled in circle, which means that the point is included. Well, let's look at the rightmost point. I think we can all see visually that that is the rightmost point. And what is the x value corresponding to that point? It's positive pi. And so that's it. That's the domain. The leftmost point and the rightmost point, and we use the x values. That's what it means to find a domain given a graph. So let's turn our attention to the range. So range, remember, it's kind of similar. It was lowest point, highest point. Let's choose the y values. So let's do that. The lowest point seems kind of like there's a tie here, which is okay. Seems like both of these points are both the lowest point. Well, it doesn't matter because they're horizontally aligned, which means they're going to have the same y value anyways. What is the y value? What's that? Yeah, it's just -1. So remember, we want the y value. That corresponds to the y-axis is the vertical line. And we see the -1 right there. Anything, we're going to start off with the lowest y value. And we're going to, again, use brackets because those points are both filled in. So we include them, which is what brackets do. The highest point, I think we can all see that it's right here, even though it's not a filled-in circle. It's implied that the graph passes through it and touches the point without any sort of issues with the graph breaking up or excluding that. In other words, just to kind of foreshadow the next problem, there's an open circle there, which means they deliberately are taking out that point. We don't see that over here on the left, so we assume that that point is included. So what is the y value for that point? Seems like it's 1. That's the y value. Do we include it or exclude it? So we're going to actually include it, which sounds weird because we were used to having these little dots. For the last few problems we saw, we're used to having these little dots there to help us. But that we use dots either to really emphasize something or to denote endpoints. For this problem, they're taking away some of that convenience that you're used to having, in a sense, to try and trick you. But you don't exclude a number unless you have to via some open circle that's there or some barrier, which I'll talk about in the next problem, is also there as well. So we're going to include 1. You assume that it's included unless there's some sort of obvious exclusion symbol, such as an open circle, a barrier. Again, I'll talk about that in the next problem, or that's all I can think of for now. Let's move on to the x-intercepts. So the x-intercepts, remember, that's when we cross the x-axis. In other words, that's when y is equal to 0. I think it's clear to see that the graph intersects the x-axis here and here. And so the directions are kind of cut off a little bit. It does want these as an ordered pair. So each one of those points gets its own ordered pair because it's its own point. Let's start off with this one right here. The ordered pair, remember an ordered pair, it's just an x and then a y. The ordered pair at the leftmost point, the x value is negative pi over 2. The y value is 0. And that makes sense because x-intercepts naturally have y equal to 0. That's an equivalent definition. And we also have positive pi over 2 with 0 for the rightmost point. So each point gets its own ordered pair. So those would be the x-intercepts. The y-intercepts, I think that's pretty clear to see that the graph intersects the y-axis up here. That's where the graph intersects the y-axis. And we want to denote that using an ordered pair. So the ordered pair for that point, remember it's x first, then y second. For a y-intercept, part of the definition is that x is 0 by default. The y value is obviously 1. So that's the y value that corresponds to that point. So we only have one y-intercept because the graph only crosses the y-axis one time. Now we move on to symmetry, something we haven't really talked about before. So I think we all have an intuitive understanding of what symmetry is, but what about if we refine that a little bit more? In other words, the symmetry in this problem, I think we can all see that there is some symmetry in this problem, but the way we quantify symmetry, at least for the premise of this problem, is it with respect to the x-axis, with respect to the y-axis, or to give another option, let me see, or the origin. What the origin means, in other words, if you rotate the graph 180 degrees, you get the same image. Obviously, you do not get the origin one here, because something facing down like this, 180 degrees is facing up like that. So origin's out. It seems like this is symmetric with respect to the y-axis, because the y-axis is acting like a mirror. Everything that happens on one side of the graph is happening on the other side of the graph with respect to the y-axis. So you would say the symmetry with respect to the y-axis. That would be it. Let's go ahead and look at the next one, and then I'll ask for any questions. So the next one, this one's a little bit trickier because, well, that open circle thing, it just kind of starts out of nowhere, and then there's an arrow as well. So some notational weird stuff. With the domain, so what does domain mean? Left and right, and we consider the x values. The furthest to the left that we can go is right here. What is the x value of that Leftmost point, -3. We ask ourselves, because we're using interval notation, do we use a bracket or parenthesis? We're going to use a parenthesis in this problem, because there's an open circle there. And as I mentioned before, an open circle means exclusion. You exclude it. You don't include it. Now, here's where this problem gets a little tricky. The furthest to the right we go, well, I see an arrow. I don't see any definitive point. I see an arrow. And naturally, when you think of arrow, you think of continuation without bound. Exactly. You keep going. But in which direction or directions is the arrow pointing in is the question. It's definitely going down forever. But what makes this problem kind of a jerk is that this problem makes you, let me erase it so I can illustrate this a little bit better. This arc right here, it's arcing in a very sharp manner. So sharp, in fact, that it wants you to make this observation that there is this invisible barrier right here. Kind of a misleading problem. That's why I wanted to talk about it. But it wants you to assume that that arc is so sharp that there's an understood invisible barrier right there on the y-axis. So that arrow means go in an infinite direction, downwards only, not to the right. So with that being said, we're not going to the right forever. So remember, with domain, it's left and right. We're not going to the right forever. Instead, we are going to stop at where the barrier restricts us at. And that seems to be at x equals 0. And that makes sense because on the x-axis here, here's 7, and there's 4, and there's 2. This is 0. So this is -3, 0. And since this is a barrier, we are not allowed to include it. Because if we were able to reach the barrier or go past it, it's not a very good barrier. So our final answer for the domain is -3 from this point over here, and 0 as implied by this barrier idea, where the graph and the barrier get forever and ever closer and closer to each other without ever touching. It's called an asymptote if some of you have taken algebra already. If not, you don't have to worry about that, but that's kind of the idea though. The range is a little bit more straightforward. The range, so remember that was bottom to top. What's the lowest point? It is going to be -infinity because that arrow definitively points downwards in a fashion that goes on forever. There's no arc of any kind that would deviate it from going down forever. So that's where the arrow, because when you see an arrow, you should definitely think continuation of this trend. But remember, there's cardinal directions, and sometimes, especially in algebra, things get tricky at times. So that arrow is pointing downwards forever. That would be -infinity. So the highest point is this one. Remember, the range wants the y values. The y value of that point, just +3. So notice we've referenced that top point 2 times, and we derived 2 different bits of information from it. The x value for the domain, and the y value for the range. For the x-intercept, well, where does this cross the x-axis? Crosses the x-axis right here. You can see where the graph goes right through the x-axis. Or in other words, what is x when y is 0? Well, here we could just count that x is -1 because the graph crosses when we just go 1 from the origin to the left. So in once ordered pairs, or just an ordered pair, so x is -1, referring to this point right here, and y is naturally 0 because this is an x-intercept. Y always has to be 0. Y-intercept? Well, so we're asking the question of when the graph intersects the y-axis. One problem with that. There's a barrier there. There's a barrier on the y-axis. We were able to touch or cross the barrier. It's not really a barrier. So none. There's no y-intercept because there's a barrier there on the y-axis. Finally, we look at symmetry. I think it's pretty clear that there's no symmetry here. Definitely not with respect to the y-axis. With respect to the x-axis, it does not reflect at all. There's no symmetry. No. The origin, you can rotate it 180 degrees. It's not going to matter. So, with those two problems in mind, in-class people, do you have any questions about anything? Check on my Google Meet people. Okay. So, y is -3 in the domain and 3 in the range, not included. So -3 is not included, and the 3 is not included. So they're both not included relative to the domain and range. If that, hopefully, oh, okay, Savannah, thank you for your, and Haley, thanks for your contributions, all of you. Okay, cool. So, all right, let's keep going. Still trying to get used to this going back and forth thing. I'll get better at it. All right, so go ahead and erase all this. We'll keep going. Right, let's move on to this problem down here. All right, let's see if I can fit everything. Okay, so we have this function, x plus 10 divided by x minus 8. Can you all see that? Okay, in here. Okay, cool. So we have this, and we're asked a bunch of questions about it. In essence, what this example does is it starts to tie in how the algebra corresponds to the graph of the function, because every function has a corresponding graph. So it's just asking for how does the algebra, various algebraic things in the graph correlate? What are some of those connections there? So the first part, part A, is the point 4, -17 on the graph. Well, how do we figure that out? We plug in, since this is an ordered pair, we plug in 4 for x, because it's the x value, and we see if the output is -17 or not. That's all that means. So now we have 4 plus 10 divided by 4 minus 8. So that will be 14 divided by -4. And you can already tell that that's not going to be 17. It's not -17. You could simplify it as -7/2. Doesn't matter. We see it's not -17. So your answer here would be no. Just be no. because in order for that point to be on the graph, the x value has to correspond to the y value. So part B, it says, all right, well, let's find a definitive point on the graph. If x is equal to 3, what is y? Let's see, maybe I'll need more room, so I'll start over here. So we're plugging in 3 for x. And so the top, we get 13. The bottom, we get -5. And so that is the y value, -13/5. It goes on to ask for what the point on the graph is. So what is this point as an ordered pair? Yeah, we plugged in 3 for x, and we got -13/5 for y. And notice I put the negative sign in the front. It means the same thing. So I think this problem has 2 parts in your homework. It would be one answer and then the other answer. So it's just more of an interpretive thing. Part C. So I think parts A and B are pretty straightforward. Part C may get a little bit tricky. So notice it doesn't say if x is 2, it says if f of x is 2. That ultimately means y is equal to 2, or in other words, set the function equal to 2. So with all these things aside, we get 2 is equal to x plus 10 over x minus 8. And then from here, we need to solve for x. It will require a little bit of algebra. If anything, you can use cross multiplication. So in red, I'll just remind everybody that 2 here is understood to be over 1. And then, of course, you cross multiply. What does that look like? It's going to be 2 times x minus 8 is equal to 1 times x plus 10. I'm keeping the denominators in parentheses because a denominator and a numerator are concrete entities. You cannot split up the terms as you please. So you have to keep the parentheses to imply the distribution that follows. You miss the distribution, you will get the problem wrong. The 1 doesn't really do anything because 1 times anything is just 1. So that's 2x minus 16 is equal to x plus 10. And I think you all see from combining like terms, it's not a stretch of the imagination to see that x will end up being 26. Just combine like terms from here. Add 16 on both sides, subtract x on both sides. You would get x is 26. So that would be the first part. The second part would say, well, goes on to say, what is this as an ordered pair? As an ordered pair, we found 26 for x. Remember, ordered pairs, x's always go first. And what was the y value we plugged in? It was 2. Okay, so we have found 2 points on the graph, the 3 comma -13/5 and 26 comma 2. Let's move on to the domain. So the domain, so we talked about this in the last class, how to define a domain if you're given a function and not a graph. That was where we had the 4 bits of criteria. Like, let me just scroll to it. So I'll come back to this. So we talked about it at the end of last class. There was this page 4 in the notes where we had these 4 conditions. I'll put the condition that applies here at the bottom where my cursor is hovering over. If a function has a variable expression in the denominator, set the denominator not equal to 0 and solve for x. Okay, well, we have exactly that. If we go back and reference the problem we have, so we don't have a graph, we have just a function. And notice with this function, we're finding the domain of it, and there is a variable expression in the denominator. So we follow that criteria exactly. What it tells us to do is set the denominator not equal to 0 and solve for x. Well, that's pretty easy. It's just x is not equal to positive 8. I can't remember if it asks for an inequality or interval notation. I'm just going to derive the interval notation just for practice. So remember what I said in the last class. It's good to draw up a number line. You plot the point of significance, and then you shade in everything else that applies. So this is what I talked about the other day. Since 8 is not equal, or we do not include 8, we put an open circle. So if x is not equal to 8, then x is equal to everything else. Everything over here, and everything over here. So interval notation requires us, so now we split up this whole number line into 2 segments. Everything to the left of 8, and everything to the right of 8. And those 2 individual components, so to the left of 8 would be negative infinity to positive 8. The union, and then everything to the right of 8 is 8 to infinity. We use infinities to correlate with those red arrows that I drew. Yes? What's that?
Was that for part E or was that for part D?
This is for part D. So yeah, it's kind of cluttered a little bit. Yeah, so this is for part, we're still on part D. So the final answer for part D, provided they ask for interval notation, is exactly this right here. If they ask for an inequality, it would be that x not equal to 8, but I can't remember. Part E wants us to find the x-intercepts, if any. And so we've been alluding towards this before, but now, mainly to find x-intercepts, we looked at a graph. Well, I think you've all noticed we don't have a graph. We have to look at everything algebraically. So one of these associations that I've been saying off to the side was with an x-intercept, you set y equal to 0, and you solve for x. Or mainly y is equal to 0, and naturally you solve for the unknown. You solve for x. So if you see x-intercept, you should think set y equal to 0 and solve for x. See if I can squeeze that in here. I'm also going to talk about this in a future section, but you'll have a few homework questions that will ask you to find the x-intercept or the y-intercept in a manner very similar to this, but that's pretty much the blueprint right there. So if you set y equal to 0, You get 0 is equal to x plus 10 over x minus 8. You're setting the equation equal to 0, in other words. When you cross multiply again, it actually works out nicely because you have 0 times x minus 8, which is just 0. And then 1 times x plus 10, which is x plus 10. So what that becomes is 0 is equal to x plus 10. And we can solve pretty quickly. And I don't think it asks for an ordered pair because it says list. Normally they'll just ask you to type in the integer or the whatever the answer is. And finally, the y-intercept, which is the complete opposite of the x-intercept. Instead of y equal to 0 and solve for x, naturally it's set x equal to 0 and solve for y. So we would end up having, see if I can squeeze this in here, 0 plus 10 is equal to 0 minus 8. Which is just 10 over negative 8, which is negative, I think I'm pretty sure they make you put a fraction, a simplified fraction at that. So what is that, 5 over 4? So that one's a little bit easier. You just change all the x's to zeros and solve for y. Or just evaluate f of 0. So that would be your answer. Does anyone have any, all right, so in-class people, anyone have any questions about this? Okay, online people, you still there? Still recording, good. All right, so now would be the time to screenshot, take a picture, whatever, or just review the video whenever I post it later today. Okay, so go ahead and erase all this stuff. Eraser. Okay, cool. So that concludes that section. There's still more stuff pertaining to the homework that is due Friday. So this would be the last section that pertains to that homework assignment, property of functions here. And we start off, so this is us slowly combining more characteristics about functions, one of which being this idea of even and odd functions, which isn't really a step further from anything we've talked about. Even and odd deals with symmetry. We already talked about symmetry in a previous problem. An even function, so an even function is when the graph is symmetric about the y-axis. So we had an even function that we dealt with before, with the pi's and everything. That was an even function. There's actually another even function on this page. So algebraically, we'll get to the algebraic definition later on, but we'll start off with the graph representation, the graphical representation. A function is odd if it is symmetric about the origin. I mentioned this before. If you want an idea of what an odd function would look like, in fact, you might even have this as a homework question. A graph that looks like this. Because when you rotate it 180 degrees, you get the same exact graph back. This would be an odd function. So let me write that down as well. So just an idea. That would be an odd function. And so moving on with all of this information we now have, we can slowly incorporate that into various characteristics we can determine about some graph that we are provided. So as you notice below, these two pictures, two different problems here, we can figure out some characteristics about them. I'm going to erase this up here and scroll down a little bit. So we're looking for the intercepts, domain and range, intervals, blah, 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 all that fun stuff. So let's see, that should do it. All right, so start off with the leftmost graph. And let's go ahead and find the intercepts, if any. So with the leftmost graph, notice that they already have these dotted red lines for the leftmost graph. So they filled in the barrier that I mentioned earlier for you. So they have illustrated that. So that's what that red dotted line means. It means a barrier. It means you don't touch it, you don't cross it. The x-intercept, well, when we look at this graph, we ask ourselves, where does this cross the x-axis? Here's the x-axis. Looks pretty empty to me. It's because that barrier up above is in the way. So it doesn't look like there's any x-intercept. Okay. Let's just get rid of that. No, it doesn't look like there's any x-intercept. Y-intercept, on the other hand, the y-axis is the vertical axis. It definitely does seem like a point does intersect it. In fact, they give us the ordered pair. How nice. Might need more room, so let me try this again. So I said none for, come on. So I said none for this one. This one, 0,8, because they gave us the point already. And we can move on to the domain. The domain, so we talked about this before. Now we're given a graph again. So remember, domain means furthest to the left. Furthest to the left versus furthest to the right. So furthest to the left we can go. Yeah, there's an arrow there. That's definitely going to the left forever. That's negative infinity because it's going to the left. So the furthest to the right we can go, we get another arrow. Yeah, so this time the arc is not sharp enough to imply that there is a vertical boundary or vertical barrier like we had in that previous problem. So in this case, the arrow means that this goes forever in the rightmost direction and up. So this would be positive infinity. The domain, in other words, is all real numbers. And also the infinities always get parentheses no matter what. You cannot equal infinity. It's an idea, not a number. So the range, the lowest point, well, lowest point I see really from the graph is here, but that does not imply that we go to negative infinity. So the graph does not go down forever. Just because there's an arrow there doesn't mean that it implies the direction that we're looking for. So we have to think about what's the smallest, and this is the range, so this is the y value. So what is the smallest y value possible? So where does the barrier happen at? So that's 1, 2, 3, 4, 5, 6, 7. Okay, seems to be 7 then. And we use a parenthesis because there's a barrier there. Can't reach the barrier. What's the highest point we can achieve? Well, that one seems okay. There's no boundaries in the way. There's no issues. It seems to be positive infinity. All right, cool. So that's the domain and range. Now we have this new idea of increasing, decreasing, and constant intervals. So I think we all have a fairly intuitive understanding of what something means for increasing and decreasing. But how do we refine that? So increasing and decreasing in constant intervals. So increasing is if something goes in a positive trend going from left to right. I think it's pretty clear here in this example that this graph is increasing. Because from left to right, it grows and gradually gets higher and higher and higher. When we denote, so we denote that interval using interval notation, and we never use brackets for increasing, decreasing, and constant. We don't ever use brackets. So you don't use brackets, and you always refer to the x values. Think about them as a domain without brackets. That's increasing, decreasing, and constant. It's just a rule of thumb, and you'll see me apply it again and again and again throughout this class. So it's increasing. Well, where's the graph increasing? Seems to be increasing everywhere. Seems to be increasing everywhere. Even over here, it never flatlines. It just, the curve gets so and so flattened looking, but it never quite flattens out. Because it can't flatten out on the barrier, because it can't reach the barrier. So it just gets closer and closer and closer to the barrier forever and ever and ever. Call that convergence. But that means that everywhere this increases. Negative infinity to positive infinity. And this will make more sense with that W problem that's coming up next about where these intervals come from. If it's increasing in everywhere, then that means it cannot decrease anywhere. So none and none, because constant means the graph flatlines some particular spot, which it does not, as I mentioned earlier. It's always increasing. Yeah, it's always increasing. Finally, symmetry. I don't really see any symmetry here. If you reflect it across the y-axis, it's not going to be the same. If you reflect it across the x-axis, it's not going to be the same. If you rotate it 180 degrees, it's still not going to be the same. So symmetry is none. So symmetry is none. Let's go through this W1 right quick. I'm running a little low on time, a few minutes left. So for this one, the x-intercepts, I see two of them. It's where the graph intersects the x-axis. We're going to go ahead and put ordered pairs. The leftmost point, we can just pretty much count and see that this is at -1, 0. The other point is at 1, 0. It's from identifying ordered pairs or points on graphs. The y-intercept is the one at the very top. That's where the graph intersects the y-axis. That ordered pair is 0, 2. The 2 goes in the y position, obviously, because it's a y value. The domain, the furthest to the left we can go is right here. The furthest to the right we can go is right there. What would be the corresponding x values? This one seems to be -3 because that comes from the x here. It's simply +3. We do include these because the points are filled in. The range is going to be 0 to 3. It's going to be increasing Well, I'm out of time. I don't like to go over. So yeah, I'll just keep it at that. So because I didn't finish the section, I'm going to push the homework back to Monday. So try to work on the problems you can work on. So you should be able to do the majority of the problems. But some of these, and if it says absolute min and max, you can skip those as well. Otherwise, you should be able to do the majority of them. Pushing the homework back to Monday. That's pretty much all I got for now. Does anyone have any questions in class, people?
I tried to submit the assignment yesterday. Did you see the work on that?
The upload.
Mm-hmm.
I'm going through all my emails today, so I'll respond to it at some point.
All right.
I got a question.
Sure, what's up?
Oh, to make sure I turn my thing on the Google Drive correct. And do today.
Yeah, I mean, the deadline's just to get people to turn it in. I just want to make sure you can do it.
Oh, I'm about to say. I think I don't want because I got.
I'm grading them today.
I'm about to say I got a classroom file. I didn't see the one with the last name. I made one with my last name and just turned it in on there.
Yeah, so you formatted it the correct way, so that's awesome. So you said you were having an issue finding the folder here.
Yeah.
All right, so I actually have a fix for that. I found out. One second. Let me stop recording.